All right, everyone, if we have a look up at the board right now, you see the answers to your homework that you had last night, Projectile Motion 2 worksheet. It was the back side of the worksheet that you got the other day. I asked you not to do question number 5, but only to take a look at the first 4 questions, 1, 2, 3, and 4. You see the answers up there? Take a look, compare them with your answers, and let me know if there's any of these questions that you need gone over. I'm going to circle number 4 right now because I'm pretty sure we're going to need to do that one. Any others besides that one? Yeah, 3 and 4. 2, 3, and 4. Sorry, there is one more answer to number 3 as well. The time was 4.4 seconds. So A was 4.4 seconds. B was 55 meters. The range downfield, that's what it asked for. How far downfield does it land? That's really the same as question number 2, right? You know, how far does it travel horizontally? Let's take a look at 2 and 4, okay? And if anybody has any issues with number 3, just stick around and we'll spend some time going over that, okay? All right, number 2. Number 2 says, a golfer is teeing off on a 170-meter long par 3 hole. The ball leaves with a velocity of 40 meters per second at an angle of 50 degrees with respect to the ground. So 50 degrees right here, 40 meters per second. We know the ball goes up like this, goes down like this, follows a parabolic path. Is that all we know? More or less, yes. 170 meters has nothing to do with the projectile motion part of this question. Because in the end, the projectile motion part of this question, we don't know how far it's going to go. The 170 meters is completely an aside to that. It's going to become important later on, but not to the projectile motion part of the question. Let's deal with this, x and y components. We know that V is equal to delta D over delta T. That's our group A equation. We also know that D for the y component is VIT plus 1/2 AT squared. V, we don't know what it is, but we can find it. We don't like funny angles. Let's get rid of the 50-degree funny angle. Here's our 40 meters per second. Here's our 50 degrees right here. This is our x side. This is our y side. Cosine 50 degrees is equal to x over 40. X ends up being equal to 25.7 meters per second. Let's find the y component. Sine 50 degrees is equal to y over 40, the opposite side over 40. The y component ends up being equal to 30.6 meters per second. So what I've done here is gotten rid of the 40 meters per second at 50 degrees and changed it into a 25.7 to the right and a 30.6 upwards. The horizontal velocity here is 25.7 meters per second. So let's plug that in now. We don't know what delta D is for the x component. We don't know what delta T is. So that's not overly helpful to me. For the y component, delta D is equal to 0 because it lands on the same level as it started. The y component, okay, it goes up, but it comes back down to where it started. dF minus di is 0. Almost crossed that off. VI isn't 0 in this question. VI is 30.6 meters per second. Multiply that by t. It's 1/2 of -9.81 times t squared. You remember yesterday we said there's 3 main differences between these problems and the problem you had on your quiz. There's this. The horizontal velocity is different because you've got to find a component of it. There's this. The vertical displacement is different. Okay, it was negative whatever. Here it's 0. Okay, and there's this, VI for the y component. VI for the y component was 0 for those horizontally launched problems. For these ones, it's a component. Okay, it's a component of the initial velocity. If we divide everything here by t, okay, this cancels out to be 0. T's cancel out here. We get 30.6. One of the t's cancels out here. 4.905 times t. When we solve for the time there in question number 2, we end up getting 6.2 seconds. Which we're going to turn around and plug back into here. Delta D over 6.2. We solve for delta D. 6.2 times 25.7 works out to be about 160 meters. Wait a second, I told you the answer was 170, didn't I? No. Wait, what did I tell you? I told you it was 10. We just got 160? That doesn't make any sense, does it? What's the deal with that, Ryan? Right. Here's the flag. The flag, we were told, is 170 meters, and that had nothing to do with the projectile motion part of the question, right? The projectile motion part of the question found us the horizontal displacement of the golf ball is 160. That's 10 meters away from the pin. So that's what we're going to do is subtract 170 minus 160. Gives me 10. Is that good? If you look at the first part of this question, that's pretty much like question number 3. Okay, the second part of this question is a little bit different, the subtraction part. Okay, let's look at number 4. That's a bit of a tough one. A cannon fires a cannonball 500 meters down range when set at a 45-degree angle. What's the velocity that the cannonball leaves the cannon? Here's the picture. It's 45 degrees. Goes like this. It goes 500 meters downrange. So the horizontal displacement is 500 meters. We want to know how fast it was moving when it started. Okay, don't know where to start here? Yes, you do. It doesn't matter what you're looking for. Even if it's a harder variable to solve for, you still start the same way. For the x component, d over t. For the y component, VIT plus 1/2 AT squared. Now, we would like to get rid of that funny angle because we don't like funny angles, but we can't. We can't get rid of it here because we don't know what the value of V is. That's what we're trying to find. Let's plug in some numbers. Don't know what V is. D is 500. Don't know what T is. D here is 0 because it ends up at the same level as it started. VI, don't know what it is. T, I don't know what it is. Okay, it's still looking kind of ugly here. A lot of unknowns, haven't solved for anything. Let's simplify it a little bit. Divide everything by T on this side. Becomes 0. 0 divided by T is 0. VI, T's cancel. Well, still don't know. Here's the crux of it now there, guys. It's a 45-degree angle. If it's a 45-degree angle, what do you know about the x and the y component? What do you know about them? Joe? They're going to be equal to each other. We know that this is going to be equal to this. So let's just call it V. Okay, let's not call it two different things now. We usually call it two different things because they usually have two different values. But in this case, it's the same value, so let's just call it V. V is equal to 500 over T. Let's change this to this. Now we have two equations and two unknowns. You guys remember from math class maybe that you can find one of the unknowns by substitution here. Okay, I'm going to rearrange this. Get T is equal to 500 over V. I'm going to take this T and I'm going to plug it back into this equation here. 0 equals V minus 4.905 times 500 over V. Now it's one equation and one unknown. What's 4.905 times 500? Somewhere around 2,500, right? But somebody figure that out, please. 2452.5 over V. So all I've done there is multiply 4.905 times 500, still divided by V. Let's take it to the other side because we want to get them on opposite sides, so it becomes positive 2452.5 over V equals V. Does that make sense? That doesn't make sense. Yeah, I guess it does. Okay, let's take the V up and square it. 2452.5 equals V squared. Square root that, what do we get? Oh, that's wrong. That's wrong, isn't it? No, that's right. What do we get there? About 50? 49 point what? 52? 49.52 meters per second. Perfect, right? I'm done. We're looking for the velocity. That's what I've got, right? No, it isn't. What have I found here? I found either the horizontal velocity or the vertical velocity, whatever you want to call it. What am I looking for? If this is 49.52, the horizontal, and the vertical is 49.52, how fast is this? That's what I'm looking for, right? So V is equal to the square root of that, 49 squared plus 49 squared. And I think it works out to be, what was it, 60 or something like that? 70 meters per second? Good? That's a tough question, hey? I'll tell you right now, guys, I wouldn't give you that question on the test on Monday. Okay? Question like number 2, yeah, that's fair enough. Question like number 1 is fair enough. In fact, you will get a question like number 1 or 2 on the exam, as you will get a question like you had on your quiz on the exam on Monday. You're going to get both of those. Okay, but you won't get one that's this tricky mathematically to solve for. All right? Yep. Couldn't you use VF squared as equal to VI squared plus 2ED? It's a perfectly valid equation. Now, explain to me how we're going to use that now. Yes, you can, but you got to be careful with that. So you understand how you're doing that. Okay, if you're setting VF equal to 0, then what you're doing is analyzing only the upward part of it. Because at the top part, the y component, it's not moving upwards or downwards, right? It stops vertically. Not horizontally, but vertically it does. So VF would be equal to 0 at that point. Okay, but if you're analyzing the entire trip, VF isn't 0. Okay, if you're analyzing the entire trip, VF becomes equal to the same thing as VI, actually. Because if you launch it up at 49 meters per second vertically, what speed is it coming down at vertically? 49 meters per second. That makes sense, Jeff? Okay, so that's a valid equation, but you got to be careful with how you're using it. Okay, you can't use that for the entire trip unless you make VF and VI the same value. Okay. Did you? By setting VF equal to 0? So what'd you solve for? You would have solved for VI? What did you set delta D equal to? Oh, you really did get lucky. You guys really did get lucky, yeah. Because 500 is the horizontal displacement, right? Not the vertical displacement. And this equation isn't even valid for a horizontal problem because that's got to be a group A problem, right? Okay, does it make sense? So you're allowed to use that with the Y component if you use it properly, but not with the X, not at all. Every once in a while you get lucky, just like you open up a book and sometimes you just end up at the right page just by pure luck, right? But usually you don't. All right, let me show you one more quick little thing here, guys. Let's say this is 10 meters per second. Let's make our angle, what do you want to make it? 30? Okay, good. Good choice. 30 degrees. We can find out how far this goes, right? We've done that a bunch of times now. But what if we got a roof? Well, this is a baseball stadium or a football stadium, and we've got a roof over top of it, and we want to find out whether it's going to hit the roof or not. We want to find out the max height. Any ideas how we might find the max height? It was interesting, Jeff, that you said what you did when you did, because it kind of actually leads into this. Even though you didn't intend that and you used the equation wrong, in the end, it still kind of leads into this. Yeah. Sorry? Hands not up? Okay. Jazzy?
So when the ball is hit right,
Yeah.
speeding up, and on the way down, it's slowing down.
The other way around, right? It's slowing down on the way up and speeding up on the way down. Yeah.
Wouldn't we get a velocity at 0?
Yes. So for the x component, v is equal to delta d over delta t, and that speed doesn't change, right? That speed stays the same throughout the entire trip. Okay, if we look at the horizontal component, it's not changing throughout the entire trip. But the vertical component of the velocity does. It slows down, it stops vertically, and then speeds up as it comes back down. Does that make sense? So let's analyze the y component, the upward motion only. And let's try this equation. Vf squared is equal to vi squared plus 2ad. Jazzy just said Vf would be equal to 0. When you reach the top, which is where you want to be, right? When you're finding the max height, when you reach the top, Vf is going to be equal to 0. Vi would be equal to, well, we'd have to break that down. The y component would end up being equal to 5.0 meters. The x component would be 8.66. You guys can do that, right, using sine and cosine. So we know what that is. A is negative 9.81. Solve for delta D. It becomes negative VI squared over 2A, right? 0 minus VI squared. Take the VI squared over by subtracting, over 2A. Same thing as saying negative VI squared over 2A. VI, the y component of it is 5. Negative 5 squared is negative 25. I'm not squaring the negative here, right? I'm just squaring the 5 over negative 19.62. That's going to give me a displacement, 25 over 19.62 of 1.4. 1.4 meters. Is that right? Is that right? Well, what have I just found? A displacement of 1.4 meters? The displacement is 1.4 meters when the final velocity is 0. So in other words, the displacement is 1.4 meters right here. The maximum height of the ball would be 1.4 meters. Does that make sense, guys? John, you had your hand up? 1.27. 25 divided by 19.62. Yeah, it would be 1.3 actually. Sorry. I tried to do that in my head and get it off by a little bit here. 1.3 meters. Is that okay, guys? That's not very much of an addition, right? All we're saying here is, look, the problems that we've done, solve them in exactly the same way. But if you get a question that asks you for maximum height, if you get one that asks you for maximum height, then just do this. There are other ways to do it as well, but this is the easiest way to do it. Hey, what if I gave you a question like this? And I said, what's the max height of this ball? That's an easy question. 20 meters. It's launched horizontally off a 20-meter high building. Its max height is 20 meters. If it's launched at an angle, well, it's a little bit harder then, but it's still not that bad. Yep. Yep. Say it again.
Going 10 meters per second at 30 degrees.
Yeah.
What we normally do get the whole bottom, like this travel.
Like here, you mean? Yeah.
30 degrees
No, no, that's a good question, but no, you can't do that. If you didn't understand that question, guys, Joe just said, look, can we get this distance right here? Okay, cut it in half, right? Because the max height is going to occur halfway through, and then just use the angle there to solve for the height, right? Using a triangle like this, right? Why doesn't that work? Why doesn't that work? John? The velocity is slowing down, and the shape of the path is not a triangle. The shape of the path is a parabola, right? So really what you've got is, if you want to analyze, I mean, you can find the horizontal displacement. In fact, it's likely that you'd have to in this question is another part of the question. But you couldn't use that to find the max height because your shape isn't a triangle. Your shape is like this. It's not even a pie shape, although it kind of looks like it. It's a parabola, kind of a half a parabola type thing. So it's a good thought, but don't ever do that because although we can do it for a very, very small area, okay, we can't do it for the trip or half the trip there because it's not a triangle. Is that good? So I was hoping to have some time to review for your test, but we don't. It's about 12:20 here. Bell's going to go shortly here. Beauty of having Physics 20 in the afternoon is what? We get scheduled help. We also have the opportunity to come and see me at lunchtime. So there's a good opportunity on Monday if you're struggling with some of this stuff to come and see me. Okay? Please, please, please take advantage of that. Please study hard this weekend. Look, you guys have worked well this year. Okay, this semester so far. You got a 94% homework completion rate. That's great. Okay? Don't abandon that now. Okay, if you've done your homework, which you have, then keep working. Okay, we can do really, really, really well on this test, but we've got to know our stuff, and we've got to work hard to know our stuff, okay? There's not any tricks on it. Okay, there's not trick questions. If you know what we've done, you'll be good on this test. But we're now putting projectile motion on the same test as we're putting, navigation problems on the same test as we're putting all of those other type problems. So the issue that people will have, if you have an issue, is that it's all together. Okay, the best way to be ready for that is preparation. Okay, work hard, study hard for it, and you should be good.